Now, next column. Okay, recursive formula. Looks scary. It's on our state standards up there. Represent sequences recursively and explicitly. Check, or half check, actually. Okay, half check, no, full check over here. And let's do the recursive. Okay, recursive, oh my gosh, Mr. Wade, I'm scared of that word. Okay, don't be. A recursive formula is stating what's happening up here. So here's how you do it. The nth term, a sub n, would be defined as, and what you have to do is state that the previous term was added by what, or multiplied by what. Okay, if a sub n is my current term, how do you name the previous term? A sub n minus 1. Put the minus 1 in the sub number, right? So it's the previous term, and what do we do to the previous term in this pattern?
Plus 5.
Yeah, plus 5. So you're just simply stating, oh yeah, it's the previous term plus 5. That's it.
Plus 5 for
Okay.
everyone.
Yes, plus 5. Actually, no, I can't do that. Okay. Now, geometric. The nth term in this sequence would be the previous term, and then what? Multiplied by 2. So every term in this sequence is 2 times the previous term. And that's how you write a recursive formula. Okay? How did I get from the last step to this step? All right. Let's see. This sequence right here. All right. Every term is actually the previous term what? Minus 1. So you could write a to the, or a sub, and minus 1, plus, all right, sorry, minus, take 3, minus 1. So you're just saying previous term, and then what did I do to it? Okay. All right, a sub n equals, let's see here. Looks like we took the previous term and divided by 2. So you can put it over 2, or usually the way that it's written is 1/2. So it's a sub n minus 1 times 1/2. That's how you get the next term. Okay. And then the last one is going to be a sub n equals what?
A sub n minus 1 plus 3.
Okay, a sub n minus 1 plus 3.
Yay!
Very nice. Very well said, Kate. Gotta love cake. Stephanie, right? Okay. All right, last column. And that is the explicit formula. Now, the explicit formula is the instantaneous formula. Like, I want to know right now, what's the 1 million in second term? All right? The explicit column is the exact same thing as something we've already done before. That is the nth term. How do you get to that one term? This is the more useful part. Okay? Try to use this one to find the 1 millionth term. All right, let me take the previous term. I don't know that one either. Okay, you have to keep going back. It's not going to work. So let's do this one. Okay, nth term. Now, 1 goes, do your chart again. 1 goes to 5, 2 goes to 10, 3 goes to 15, 4 goes to 20. Notice anything in common with these numbers right here? Mm-hmm. They are all times 5. Okay, 5 times 1, 5 times 2, 5 times 3, 5 times 4.
5 in.
Okay. So it's going to be 5 times n is the pattern. Thank you. Okay. And you know what? When you look at that nth term, by the way, that's actually y equals 5x. That's how you know that it's linear. That's what that equation is right there. Okay. All right, this one right here. A sub n equals, okay? Geometric, so it's going to be a what type of answer? Geometric. Multiply, multiply, multiply. What does that graph?
Exponential.
Exponential. So this is actually going to look like an exponential right here. So it looks kind of like an e to the x. Okay, so I go from 1 to 5, 2 to 10, 3 to 20, and 4 to 40. Okay. See any like terms here or any common factor? 5 again. 5 times 1, 5 times 2, 5 times 4, 5 times 8. More sophisticated than the last time. Anything special about 1, 2, 4, 8? Look lower down because you can see it better when you look lower down here.
Square root.
Wait, 8 is 2 cubed. That is squared. That is first, and 1 is
2 to 0.
2 to the 0. Nice. You know where all those 2's are coming from? you keep multiplying by another 2 in every step. So you multiply by another 2 and another 2, and that exponent is skyrocketing. Okay? So the pattern is, what do we start with?
2.
Okay, do this in reverse. 5 times 2 to the 4 became 3, 3 became 2, 2 became 1, so it is to the n minus 1 power. Okay? And you know what? That is exponential, isn't it? 2 to the n minus 1, you betcha. Okay, you got it. All right, nth term. Okay, so for this one, now this one's a little trickier. 1 to 8, 2 to 7, 3 to 6, 4 to 5. It's a little harder when they're decreasing, so here's kind of the best strategy for this one right here. What I would do is, I would base it on the first term and kind of what happened to it, okay? Oh my gosh. I love teaching math, I mean. All right, this is actually 8 minus 0. You didn't do anything to 8 yet. This is 8 minus 1. This is 8 minus 2. Notice what's happening to the 8. You're taking away more and more and more. So for a decreasing sequence, I would start with the original number. So you know what it is? It's 8 minus, what is that? That's n minus 1, exactly. So 8 minus n minus 1. Okay? Or if you want, you can go ahead and distribute, that's fine too, that's okay, but you can do this, and what is that, 9 minus n? You can simplify, so either one's fine, okay? All my heavens. Okay. The last two are actually very similar to the ones we just did, okay? So, let me give you a souvenir. I don't have a catchphrase yet.
No, you don't.
Catchphrase.